So now I'm going to talk about tutorial number 3, which is similar to the assignments that we have. So, no, not this circuit. Yeah, this is power system. So let me talk about the assignments. This is assignment number 3. Yes, this assignment. So for assignment number 3, we have two different problems at the beginning. This problem and this problem, both of them are talking about Wheatstone Bridge. Do you remember that? And we have problem 3, problem 4, problem 5. All of them are talking about node voltage methods. So let us solve the tutorial and see if you would like me to go over the assignment or the tutorial is enough, because the tutorial is talking about the same story. I give you two different problems which are similar to what we have, and I give you here 3 different problems which are talking about the problem 5, problem 6, which are talking about node voltage methods. But why I don't have figure 4? Yes, this one. So let us talk about these problems. Number 1, problem number 1 is telling me a circuit which is shown in figure 1 consists of 2 resistors with resistance R1, which is equal to 5, and resistor R2, which is equal to 2, variable resistor and VR variable. Its name is R variable, and it could be adjusted, and a resistor of unknown value, which is RU, this guy. He is telling me when and 10-volt battery. So this battery is 10 volts. He's telling me that this guy is 10 volts. When where is it? When R variable is adjusted to 10 ohms, he is telling me that when R variable is equal to 10 ohms, there is 0 current. So if this guy is equal to 10, the current is equal to 0. So right now, he gave me R1, R2, and R variable. What's needed? What is the unknown RU? Straightforward the problem. If you still remember, if you would like to solve for finding RU, what you have to do is, since there is no current between A and B, what is the relation between VA and VB? They are equal, so I can say VA is equal to VB. If I assume that this is my ground, I can say the voltage across VA is equal to the voltage across VB. Can you please find the voltage across VA by using the voltage divider? Since there is no current here, I can imagine that the current here is the same like this current. Am I right? Which means, as if those two are connected in series, which means the voltage across this guy is equal to the total voltage between C and D, which is 10, divided by the summation of R1 and R variable, multiplied by R variable, based on the voltage divider, right? So I can say VA could be represented by 10 divided by R1 plus R variable multiplied by R variable. And by the same way, I can say VB is represented by 10 divided by the summation of R2 and RU multiplied by RU. Yes. I can cancel this guy with this guy. At the end, I can rewrite these equations as R variable divided by R1 plus R variable equals RU divided by R2 plus RU. Then I can simplify this to be R2 times R variable plus R variable times RU, which is equal to R1 RU plus RU R variable. This guy could be cancelled with this guy. At the end, I will have R2 R variable equals R1 RU, and we are looking for finding RU, so I can say RU is equal to R variable divided by R1 multiplied by R2. So I can substitute by the value of R variable that he gave it to me. I believe R variable is adjusted to be, he said R variable is adjusted to be 10. So I can substitute by R variable, which is 10. Am I right? He said R1 is equal to 5. And he said R2 is equal to 2. And he gave me R variable, which is equal to 10. So I can substitute by these values for finding the value of RU. I can calculate the value of RU based on that. Any question? Yes. This guy is R1, yes, this is U. It's not 2, yes. It's U here. Yeah. Thank you. Any other question, guys? Yes. Yes. That's fine. If you know the formula, you can use it. If you know the formula, you can use it. But I don't prefer to memorize anything. I'd like to derive it. I will distribute a formula sheet, but the formula sheet will not have that equation. So if you memorize it, that's okay, but I don't like you to memorize it. Now, let us see another problem. So problem number 2, he gave me similar circuit, yes. For what? What he said, he said, I have 2 resistor, variable resistor, and a known resistor and 10 voltage battery, which is this voltage. The battery has 10. So the voltage across the battery is 10. This is what he said here, and 10 voltage battery. Okay. So if you would like to find the voltage across this guy, it's equal to the voltage between these 2 points divided by the summation of those multiplied by R value. And this is what I did here. Got it? Now, for problem number 2, he is asking about the same story. He said, for this guy, it's Whetstone Bridge. Solve the following problem. If R1 is equal to, R2 is equal to, Rx is equal to what value should R3 to be adjusted to achieve a balanced condition? So he gave me Rx, which is 5. He gave me R2, which is equal to 3. He gave me R1, which is equal to 2, and he is looking for R3. I think I can use the results that I got from this one, because it's similar to this one, to calculate the value of R3. So if you want, I can say for part A, R3 is equal to R1 times Rx over R2. And if you try to substitute, it will give you 1.5 ohms. Based on the identity that I have already derived here. So if you try to look to this identity, RU, which is this guy, it's equal to R variable divided by R1 multiplied by R2. So if you are looking for this, it is R variable divided by R1 multiplied by R2. The same here. If you are looking for this, so it is equal to Rx divided by R2 multiplied by R1, right? So if you are looking for this guy divided by this guy multiplied by this guy, and vice versa. If you are looking for this guy divided by this guy multiplied by this guy. Excuse me? Yeah, but he said there is no current. There is no current in this guy. This is what he said. As if this guy is nothing. Okay? If you try to read here, he said R3 is adjusted to achieve the balanced condition. What is the balanced condition? There is no current in this guy. Here, why you didn't say the meter has a resistance as well? The meter has resistance, but we didn't consider that. Why? Because he told me there is no current in this guy. You got what I mean? Any other question? Yes. Excuse me. For question number 2, the answer will be R1 times Rx divided by R2. We think R1 is 2 times Rx, which is 5, divided by 3. It is what it is. You will substitute the values. So you will have R1. Oh, this guy. Yes, this guy should be. I will substitute here. Probably I didn't calculate it right. So R1, which is 2, multiplied by Rx, which is 5, divided by 3. Yes, it is what it is. 2 times 5 divided by 3, approximately equal to what? 3 point something? Yeah, so I wrote it 1.5. I'm sorry. It's a 3 point something, yeah. Any other question for this problem? Now, let us see the second part, because the second part is good. The first part is substitution, and it is straightforward. The second part, he is telling me if VO is equal to 5. So VO is given, which is 5. And R is equal to 0.3. So he gave me the value of RA. Now, I have this circuit. I will put it here again. So what he gave me for this circuit, he gave me the value of RA, which is 0.3. And he gave me VO, whereas VO, which is this guy, it is 5 volts. And he said an Rx were then to B2. So Rx, it is a change it to B2. And what about R2? It doesn't change. And what about R1? It doesn't change. So he's saying, what would be the reading of the ammeter? Right now, this guy is a change it to B2. And this guy is 0.3. Since this guy is a change it to B2, are you expecting there will be a current here? Yes, for sure. At that time, I have to know the value of RA. Because of that, for this part, which is part B, he gave me RA. But in the first part, why he didn't give me RA? Because I don't need it, because there is no current in RA. But what about here for this guy? No, there is current. Why? Because R is equal to 2 is not the balanced condition, which means there is a current here. So he asked me, what is the reading of the ammeter? How to solve such a problem? what I have to do for solving such a problem, I have to assume the current in this branch, he gave it to me I1, and the current in this branch I2, and the current in this branch IA, and the current in this branch I4, and the current in this branch I3. But what is the next step? I will try to solve the problem using whichever method you learned to calculate the current in this guy. Which method you like to use? It doesn't matter. Which one you like to use? Excuse me? Which one you like to use for finding the current IA? Excuse me? What are you saying? Okay, Kirchhoff's voltage law and Kirchhoff's current law. If you try to use Kirchhoff's voltage law and Kirchhoff's current law, I have 1, 2, 3, 4 nodes, but probably I'll deal with the 3 of them, and I'll see if I need the 4th one or not. And then I'll say summation of the voltage here is equal to 0. Summation of the voltage is equal to 0. Summation of the voltage is equal to 0. I have 3 other loop equations. So if this is the direction of the current, I'm expecting positive, negative. I'm expecting positive, negative. I'm expecting positive, negative. I'm expecting positive, negative, positive, negative. So I will say summation the current for node O is equal to 0. Summation the current for node 1 is equal to 0. Summation the current for node 2 is equal to 0. So summation I is equal to 0 for node 1. For node 1, I have here this current, I have this current, and I have this current. So if I assume I1 has positive sign, IA and I3 will have negative signs. So I can say I1 minus IO minus, IA minus I3 is equal to 0. Then summation I is equal to 0 for nodes 0. Which is that guy? Actually, I have a current here, which is I, for example, and I have I1 and I2, so I can say I minus I1 minus I2 is equal to 0. Then summation I is equal to 0 for node 2. This is node 2. I have this guy is entering, this guy is entering, and this guy is leaving. So I can say that I2 minus IA minus I2 plus IA minus I4 is equal to 0. Is there any mistake? Okay. Now, how many equations? 3. And how many unknowns? I1, I3, I2, I4, IA, and I. 6 unknowns. So I'm expecting 6 equations. So I can say summation the voltage for this loop is equal to 0. Summation the voltage for this loop is equal to 0. Summation the voltage for this loop is equal to 0. To be honest with you, I think I don't need this equation. Why I don't need it? Because this equation is function of I. And when I said summation the voltage here is equal to 0, summation the voltage for this guy is equal to 0, summation the voltage for this guy is equal to 0. Are we seeing I for the voltage? No. Are we seeing I here? No. Are we seeing I here? No. So probably I don't need this. I'm trying to minimize the number of equations as much as I can. If you're not, that's okay. So imagine that this is loop number 1, this is loop number 2, this is loop number 3. So summation V is equal to 0 for loop 1. So I'm moving in that direction. The second sign is positive. The second sign here is negative. The second sign here is negative. So I will say VO, which is given. I don't remember its value, which is 5. I don't like to write unknowns, so I will write it 5. Then minus 2I1 minus I3 times R3. What is the value of R3? You give it to me, I believe. R3, yes, I have already calculated. You said it is equal to what? 3.1? Okay. So 3.3 multiplied by I3 is equal to 0. Then summation V is equal to 0 for loop number 2. For loop number 2. I will go that way and keep the second sign. Rx is changed. Oh, I'm sorry. So Rx became 2. Yes, I wrote it 2. I wrote. Just 1 second. I'm not hearing what you're saying. Yes.
Yeah, all one is.
Please leave her to talk. I'd like to listen.
Changed Rx from
Yeah.
5 to 2, so using it in the calculation, it should be 2 times 2 divided by 3. You want to use the R3 because you changed the answer.
No. Why? Because he didn't talk about R3. He didn't talk about R3 at all. Did he talk about R3? He used this circuit to find the value of R3. And this guy is adjustable resistor. So I was playing with the value of R3, but this guy is fixed value now. You got what I mean?
Yep.
So it doesn't change. Did I answer that question, guys? Any other question? Okay. Now, summation the voltage for loop 2 is equal to 0. What I have 2 times I1 with positive sign minus 3 times I2 plus 0.3 times IA is equal to 0. Then last one, summation V is equal to 0 for loop 3. For loop 3, I'm moving in that direction. So the second sign here is negative. The second sign here is negative. And the second sign here is positive. Am I right? So I will have 0.3 IA minus 2 times I4 plus R3, which is 3.3 times I3 is equal to 0. Now I have 5 equations. I have to solve them for finding the answer. Which one? This guy is negative, then positive. This guy is negative. Yeah, this is negative. You are not seeing it? The electronic pen didn't write it. I told you it is negative. And I said negative, but probably the electronic pen didn't write it. It is the mistake of the pen. It's not my mistake. Any question, guys? So, if you asked me, am I going to give you a problem like that for the final exam or the midterm? The answer is no, because you have 5 equations and 5 unknowns, and you need time to solve that. But for the final exam, I'm not going to give you like 5 equations and 5 unknowns. It's too much. It's consuming the time. And I'm not testing you in mathematics. I'm testing you in electric circuits. So I'm not going to give you 5 equations and 5 unknowns. Probably like 3 equations, maybe 2 equations. It depends on the problem. Now, can I solve this problem by using a different way to minimize the number of equations? The answer is yes. I can use, like what he's saying, convert delta to star and find I total, right? And after that, start to distribute I, but I'll leave it to you to solve it if you want. But pay your attention. If you converted delta to star, you are going to convert this guy. And you would like to find the current in this guy. So after finding this current and this current, you have to redraw that part again. And to try to say summation the current is equal to 0 for nodes to be able to find the current in this guy. But I can use another method, which is what? Nodal analysis. So I can connect this guy to the ground. Then how many nodes left? 3. This guy, this guy, this guy. Do I need to say summation of the current for this guy is equal to 0? No. Why no? Because the voltage is given 5. I can say summation of the current only for this node is equal to 0 and for this node is equal to 0. At that time, I can solve these two equations, right? And find V1 and V2. Once you found V1 and V2, you can calculate this current because this current is V1 minus V2 over 0.3. Are you seeing what I'm talking about, guys? So I can give you a problem like that. And some of you will solve by using KCL and KVL, 5 equations and 5 unknowns. And then they will start talking about me by saying some bad words. This guy is tricking us. He said, I will not give you problem to solve it by using 5 equations and 5 unknowns, but he is giving us that. But you can solve it by using 2 equations. And this is what I'm looking for. Are you seeing what I'm talking about, guys? So if you are solving midterm or final exam and you found many equations and many unknowns, maybe you are not using the right way. You have to think. So if I try to resolve this problem, let me copy this guy for you again and write here, because the purpose of today's class is to learn. So if I try to solve this problem using node voltage methods, imagine I would like to use using node voltage methods. So this is my reference, and this voltage is VO, which is given, I think it is 5. He gave it to me, which is 5. And I will say that this is node number 1 and this is node number 2. So I'll say summation I is equal to 0 for node number 1. So I will not talk about I1, I2, I3. Why? I don't need them. I'll talk about this current, and this current. So I will say this current is V1 minus VO, so V1 minus 5 over R1 plus V1 minus 0 over R3 plus this current, which is V1 minus V2 over RA equals 0. Then summation I is equal to 0 for nodes 2. At that time, I have this current, this current, this current. So this current is V2 minus 5 over R2 plus V2 minus V1 over RA plus V2 minus 0 over Rx, which is equal to 0. Then I have 2 equations. I can solve them. Very easy and straightforward. If I try to use node voltage method, it will be very easy problem to be solved. 2 equations only in 2 unknowns. Any question? Let us solve more problems related to node voltage method. Do you need that? Yes, go ahead. I'm not leaving you. How I do what? V2 minus 0. Okay. Are you seeing the bottom nodes? It's connected to the grounds. So its voltage is 0. Any question? Yes. 10 I. The problem here, this guy is considered as the bottom node is considered as a reference node. So I'm not going to look to the whole node as so because this is my reference. I have to have a reference node. You know what I mean? Let us solve more problems. I'll try to solve very quick. Use node voltage method to calculate I1, I2, I3. I think this problem is straightforward. It's similar to the problems that you have in the assignments. So if you try to solve such a problem, he gives you that this guy is the reference, and this guy is VB, and this guy is VA, and this guy is VC. But what is VA? Yes, it's 10. What's VC? It's 20. So he would like to calculate I1, I2, I3. It's very easy to calculate VB. So I will say summation I is equal to 0 for node B. So I'll assume all currents are leaving. So this current is VB minus 10 over 10 plus this current is VB minus 0 over 40 plus this current is VB minus 20 over 20 is equal to 0. Now I can solve that problem for finding, or that equation for finding VB, which is equal to 80 over 7 volts. Now he is looking for calculating I1. It's straightforward. I1 is this voltage, this current, which is equal to this voltage minus this voltage over 10. So it is 10 minus VB, which is 80 over 7 divided by 10 amps. And I2 equals, which is this current, VC, which is 20, minus VB, which is 80 over 7 divided by 20 amps. And the last one, which is I3, actually I3 is this current, which is VB, which is 80 over 7 divided by 40 amps. By doing that, you have already calculated I1, I2, and I3. Any question? Which term you are talking about? This one? So here it is VB minus 20 over this resistor. And this guy is VB minus 10 over 10. And this guy is VB minus 0 over 40. Did I answer your question? Okay. Any question, guys, for that problem? Yes, go ahead. VB, yes, VB minus this voltage over this guy. Because this is the direction for I1. When I try to say summation the current for this guy is equal to 0, I assume the current is going from VB to VA. But right now I would like the current to be from A to B. That's why I changed the order. You got what I mean? Any, yes. Yes, yes. If, like, what she is saying, what's your name? Rory, like, what's Rory saying? If I assume that all currents are hitting the node at that time, and instead of saying VB minus 10, I'll say 10 minus VB and 0 minus VB and 20 minus VB. But I prefer to assume all currents are leaving because I don't like to see this negative sign here to make it more easier for myself, just in case if I forgot. But do whatever you want, it's your problem. Any question, guys? Let us see problem number 4. Do you like to have a break or continue? Continue? We are almost there. So use the node voltage method to calculate VB. And the current in 20 ohms, he would like to calculate the current here in this guy, in the circuit of this figure. So again, how many nodes do we have? Yes, I can consider this guy as 1, and I can consider this guy as 1. So the voltage for this guy is VB, and I'm assuming that the name of this node is B. This is straightforward the problem, but extra problem which is talking about node voltage method. So I will say summation I is equal to 0 for node B. I'm going to assume all currents are leaving the nodes. So this current will be equal to VB minus this voltage, which is 140 over 20. So VB minus 140 over 20 plus this current, which is VB over 6 plus this current, which is VB over 5 plus this current. Rui, what is this current? It's minus 18, yes. So minus 18, like what you said. Why here I preferred that all currents are leaving? Because if you try to assume this current is hitting and this current is hitting at that time, what is this sign? This sign will be negative and this sign will be negative because I will have 0 minus. Are you seeing what I'm talking about? Everybody, any question? Am I fast? Am I too fast? Okay, I'll slow down. Yes. Could you please repeat? Yes. You mean parallel? No, they are not connected in series. They are connected in parallel in all cases. Because parallel means I have 2 resistors connected between 2 nodes. And this is the story. But series means I have 2 resistors and there is no distribution in between. They have the same terms. So here, these 2 are connected in parallel. One is turning off. Someone is doing that in the back.
I think it's on the top.
Okay, I didn't figure it out, but I asked. Maybe someone is breaking us from the back. But that's good. It's turning on and off because it works. It woke up us, you know. We are waking up. There is a change. Any question on that problem? Any question? Okay, let us see another problem. If you try to solve this for finding VB before leaving it, what I will have right now VB. If you try to solve it, I think VB will be equal to 60. And he asked me as well to calculate the current in 20 ohms. He would like to find this current. What is the direction for that current? Which direction you like? It doesn't matter. It depends on the voltage. Here you have already calculated this is equal to 60 volt, and you know this guy, it's 140. So what is the right direction for the current in 20 ohms? From left to right or right to left? From left to right. So it is in that direction. So I can say this guy is I, and I is equal to the higher voltage minus the lower voltage divided by 20, and this guy will be equal to I think 80. Am I right? 80 divided by 20, which approximately equals 4 amps. Any question for that problem? Yes. Can I show you what? Number 3, yes. What do you want? Oh, he asked about the total power dissipated. I'm sorry. I forgot that. Now, if you would like to find the total power dissipated, this guy is generating or dissipating power, and this guy is generating or dissipating power. In other words, those two sources are active or passive. You are saying passive and you are happy? You have to regret about yourself. You are not understanding. So how come I have two sources passive? From where there is a generated power? At least one of them should be active. Am I right? Okay, how am I going to know that this is active or passive? If the direction of the current from negative to positive, negative sign to positive sign, from low to high, this is active, right? So here, this is negative and the top one is positive. And this is negative and the top one is positive. Did you calculate I1? Yes. I1 is equal to 10 minus 80 over 7 over 10. Can anyone calculate I1? Is it negative or positive? Anyone calculate it, please? And give me the number. Negative what? The number. Give me the number, decimal number. Negative 0.14. Okay, what about I2? I2 0.43 amps. Did anyone check? Okay, now based on these values, for sure I can say that this guy is active element, but the other one is passive. This is active and this one is passive. So if you would like to calculate the power dissipated, it is equal to the power in this guy plus the power in this guy plus the power in this guy. So it's equal to I1 square times 10 plus, see the pen is not writing, plus I2 square multiplied by 20 plus I3 square multiplied by what? By 40. Don't forget plus I1 times 10, not 10 only. 10 multiplied by 0.14. Why 0.14 with positive sign? Because based on that direction, this guy looks like active element. So its power is equal to negative V times I. But if I substitute it by V, it's 10. And I, it is negative 0.14. At the end, I'll have positive sign. Are you seeing what I'm talking about? So if you considered 10 volt as active, what you have to do, you will write the power in this guy is equal to 10 multiplied by I1 multiplied by negative sign. But I1 is negative. So the total sign will be positive and it became passive. So that's why I wrote all of them here. And then you will write the power generated. It is equal to the only source, which is this guy, based on the number that I got. If what we did is right, if there is a mistake in the calculation, everything will be wrong. If there is only simple mistake, everything will be wrong. I'm solving based on what we got. So I2 times 20, because this is passive, sorry, this is active, so minus V2, or I can say 20, sorry, 20 times I2, so 20 times I2. This guy in watts and this guy in watts, and both of them, those should be equal. If they are not equal, there is a mistake in the problem. The magnitude should be equal. If they are not equal, there is a mistake in the problem. Any question? Now let us see. By the way, I will upload that on Brightspace. So if you missed something, that's okay. Use node voltage method to calculate the current in R1 and R3 in the circuit of figure 5. So how many nodes do we have? 4. Which one you would like to connect it to the ground? Okay, tomorrow I will solve another problem by connecting this guy to the ground. But I'll do that tomorrow, not today. So tomorrow I'm going to solve similar to this problem by connecting this guy to the ground instead of this. And I'll show you what's going to happen. What will be the difference? To show you if solving the problem by considering this guy as a reference will be more easier or keeping this guy as a reference. Now, I will have this guy, I will have this guy and this guy, but I have to ask myself the question. Should I say summation of the current for each node is equal to 0, or try to define the voltage for each node first? The answer is I will define the voltage for each node first. The voltage for this node is it's unknown, so I'm going to assume it, for example, VA or V1. The voltage for this guy, is it given? I have the current. So the voltage for this guy is, this is the current. So the voltage is, it's unknown, yes. I'm trying to trick you. So the voltage is unknown. I'm waiting to catch that guy who's going to say, oh, it's equal to 0.375. Some of you will say that, I'm sure. So this guy is V2. I'm going to say summation the current for each node is equal to 0. Summation the current for this node is equal to 0. Summation the current for this node is equal to 0. I'm going to assume all currents are leaving for all nodes. But just 1 second, what do you need? You need to find the current in R1. Once you know V1, you can find the current in R1. And you need to find the current in R3. What is R3? This guy. Oh, so I need to know V2. Why I'm asking myself that question? Because if I don't need the current in this guy, no need to calculate this voltage and say summation of the current here is equal to 0. But the problem is, if you set summation of the current here is equal to 0, you have to know this voltage. So even if I didn't ask you to calculate the current in this guy, you have to write the equation of the voltage for this. You have to know V2, because to know the current, to say summation of the current here is equal to 0, you have to know this current, this current, this current. Let us see. And this third node that has 8V, should I say summation of the current for this guy is equal to 0? No. Why no? Because I know the voltage. No need to say summation of the current for that node is equal to 0. Unless I ask you to calculate the current here. Okay, guys? Are you started sleeping? Do you like me to tell you a story? To sleep and snore? Start snoring? Did I tell you about the apple? The teacher was teaching her student about how many apples to. She was teaching her student to count. How to count? Did I tell you about that? Okay, I'll tell you. Do you like me to tell you now or later? Okay, I'll tell you, but I'm recording. Okay, so there was a teacher, she was teaching her student to count how many apples. And then she gave her student like 2 apples and let us say 3 apples. So she gave John 3 apples. And she knows that John is the best student in the class. And she gave John 3 apples, and then she asked him, John, how many apples do you have? John is a smart guy. Every time the teacher is saying good things about him, and John said, oh, I have 4. Then the teacher started staring to John, and everyone started laughing. They were waiting for John to make mistake because he is the smartest one in the class. So everyone is jealous from him. So everyone started laughing because John did a mistake. Then the teacher was angry from John, and she gave him again 3 apples. And she told him, John, those 3 apples, how many apples do you have? And John started thinking, oh, did I make any mistake or what happened? John said again, oh, I have 4. But, you know, he was scared from her. Then she took the apples and threw them away. And then she brought 3 oranges and she gave him those oranges. And then she asked him, John, how many oranges do you have? He said 3. She was so happy from him. And then brought the apples again, and she gave the apples to John. John, how many apples do you have? He said again 4. Then she asked him the question that she was supposed to ask him from the beginning. Why did you say 4? I gave you 3 and I told you 3. Why you are saying 4? John told her, do you know what? He told her, you give me 3 and my mom puts another one in my bag, so I have 4. Anyway, it's silly. So let us, no, I'm not that good guy to say stories, but you know, I don't like you to sit for like 3 hours without taking a break, and this is our break. I need only like maybe 15 minutes to complete that part. I'll see. But you will sleep because I'm a boring guy to tell you jokes. Maybe I'll ask some of you. So let us see this problem, problem number 5. He is telling me that he would like to calculate the current in R1 and R3. So if you would like to calculate the current here and there, I have to find the voltage V1 and V2. But again, I'm not calculating this. I'm not saying summation the current here is equal to 0 because I know that voltage. Am I right? So I'll say summation the current for node I is equal to 0. 1. So this current is V1 minus 8 divided by 40 plus this current is V1 divided by 20 plus this current is V1 minus V2 divided by 40. This guy is equal to 0 and this is equation number 1. Summation V is equal to 0 for loop 2. For node 2. So for node 2, I can say this current is V2 minus V1. divided by 40 plus this guy is V2 minus 8, am I right? Divided by 20 plus this guy, which is, yes, minus 0.375, which is equal to 0. This is equation number 2. Then, by solving these two equations, I can calculate VA and VB. So if you try to calculate VA or V1 and V2, you will realize that V1 should be equal to 5 and V2 should be equal to 12. Once you calculated V1 and V2, this is volt and this is volt. You will be able to calculate the current in R1. So the current in R1, if this guy is 5, if this guy is 5, the current in this guy is equal to what? The current in this guy. Is it 8 minus V1 or V1 minus 8? This voltage is 5. It's 8 minus V1, which means this will be the direction for my current. This guy I1. So I can say I1 is equal to 8 minus V1 over 40. What about I3? If this guy is 12 and this guy is 5, so this will be the direction of the current. Am I right? So this will be I3. I can say I3 is equal to V2 minus V1 over 40. Amps and amps. Any question? Last question that we would like to solve it before leaving. This will be our last question. But before solving that question, I'd like you to see these questions again. This problem number 1, problem number 2, similar to what we have already solved. This guy, I can choose this guy to be my reference node. Then I have 1, 2, 3 nodes. Am I right? And what about this? All of those will be my reference node, right? Then I have this and this one and this one. Can I consider this guy a super node? Yeah, so I'll have 2 nodes. The same here, if this guy is connected to the ground, I can say I have this node and this node, and this is not considered as essential node. Am I right? I can add this to this. And then I can consider this as what? Super node. I'll have one equation in whichever the number of unknowns. Let us solve problems similar to what we are talking about. I have here 4 different nodes, but if you try to look to them, actually, these 2 are considered as one node, right? And this guy has node, and this guy is node, so I can say this guy is V1 and this guy is V2. If you didn't realize the super node, it is okay. But if you realize the super node, it will be more easier for you to write only one equation. Do you like to say summation, the voltage, the current for the super node is equal to 0, or step by step use each node, which super node? Okay, so I will look to this guy as super node. And then I'll say summation, the current for the super node is equal to 0. I forgot to read what he is looking for. He would like to calculate the current in R1, so he needs V1, and R3, he needs V2. So I will say summation I is equal to 0 for super node. So all currents are leaving. So this current is V1 minus 24 divided by 150 plus this current is V1 minus 0 divided by 100 plus this current is V2 minus 0 divided by R3 plus this current, which is negative 0.1 equals 0. I need another equation. What is that equation? Yes, I need the difference between V1 and V2. V2 or V1 minus V2 is equal to 6. which one minus? Yes, V2 minus V1 is equal to 6. I think we can solve these two equations together, and we can find V1. You will find it's equal to 6, and you will find V2, it is equal to 12. If you try to calculate them. So one is 6 and another one is 12. Once you calculated V1 and V2, you can find the current in R1. So the direction of the current in R1 from left to right or from right to left? Yes, because this guy has higher voltage than this guy. So this is the direction for the current I1. I can say I1 is equal to 24 minus V1 divided by 150. And by the same way, I can calculate I2 in R3, or I can call it I3, which is this guy. This is I3. So it is equal to V2, which is 12 over 75. Am I right? Yes. This one. So what I would like you to put in your minds and keep it in your mind. Node voltage method is one of the best methods that you can use for solving any problem. So if you got lost and I didn't ask you whichever method you can use, I think node voltage method is the easiest one. But pay your attention. For node voltage method, there are some things. Pay your attention to the supernodes. Pay your attention to the nodes that has given voltage. No need to start talking about that nodes. And that's it for the supernode and for node voltage method. I'll see you tomorrow morning to continue talking about what's left for node voltage method, and we will talk about mesh analysis as well if there will be a time. Thank you so much for listening, and have a great night. See you tomorrow morning, and sorry for being late.